Hey everyone, in today's video we want to talk about the graduate record examination, which is abbreviated as GRE, but we want to focus more on the quantitative reasoning aspect of it. We are going to look at the topics and then some key strategies, very simple ones that you can use to solve these quantitative section problems. But before we go into that, let's have an overview of the GRE Quant section. Now, as at September 2023, there is a new format where you have two scored quant sections of different fixed length. So the first section has 12 questions and you do that in 21 minutes, whilst the second section has 15 questions in 26 minutes, and that will give you 27 quant section problems in a total of 47 minutes to solve them. Then the section level adaptive, that is how well you do on section 1, determines whether section 2 is the easier or harder version. So there's no strict easy to hard order within a section. So don't assume that question 1 or a particular question is easier than the other one. Then there is a basic on-screen calculator that is provided. Take note that this calculator does not have scientific functions. You just needed to do some simple calculations. Right, it helps with tedious arithmetic, but isn't a substitute for reasoning. Then the scoring. So it ranges between 130 to 170 per measure. Now, mind you, with the GRE, we have the verbal aspect as well. So both the verbal and the quant, the score ranges between 130 to 170. And there are no penalty for wrong answers. So never leave a question blank. The full GRE test has these components: the analytical writing, the verbal reasoning section, and then the quantitative reasoning section. And now, altogether, it takes about 1 hour 58 minutes to finish the whole test. All right. Now, what are some of the topics tested? Now, under arithmetic, we have integers, fractions, decimals, percentages, ratio and rate, exponent and root, number properties like even and odd numbers, prime numbers, divisibility rules, Remender's theorem, and all that. You will also find absolute value, the number line sequences, and the rest. Now, under algebra, you meet questions under linear and quadratic equations, inequalities, exponent rules, some factoring, functions, coordinate geometry, that is graphs of lines or equations, slopes, and then intercept. Then under geometry, you meet lines and angles, triangles. You must know all the types of triangles here. And one key thing you should know is the Pythagorean theorem. You meet circles, quadrilaterals, or polygons, three-dimensional figures, that is volume, surface area. One thing you need to take note is that the figures are not necessarily drawn to scale, right? And this is a key trap that you need to look out for. That is why I'm mentioning it in my video. Then you also look at data analysis, right? So the mean, median, mode, range, standard deviation, probability, counting methods, permutations and combinations, and interpreting data in tables and in graphs. So these are the topics you should look out for. All right, now let's look at the question format. How do they look like? So we have quantitative comparison. So some of the problems, you're going to be given some quantities to compare them. So always you're going to compare quantity A and quantity B. And there are some options you are going to select. Either quantity A is greater or quantity B is greater, or they are the same. Both quantities are the same. Or the last choice where the relationship cannot be determined from whatever conditions that are given. Then we have multiple choice questions where you select one answer from the standard 5 options that you have. Then we have the multi-choice. So with that one, you select one or more answers, right? So those comes with boxes that you're going to tick all the correct answers you think they apply. Then the numeric entry. Here, you are going to put in your answer into a box. There will be a box provided, and then you solve and then put your answer inside. Then we have data interpretation set, where 2 or 3 linked questions based on the same shared table or graph, and you use that to answer the problems. All right. So let's begin with the strategies. The first one is what I call the picking smart or strategic numbers, right? And here you need to be careful. So when a problem has variables but no specific or special numeric constraint. Don't grind through algebra. You don't want to do a lot of calculations. You just have to plug in simple numbers, or you test simple numbers. This can be 0, 1, -1. You can also do with fractions and negative numbers as well. Here, you want to do that to see how the relationship behaves, right? If different valid numbers give different outcomes, then of course you are going for the answer option D, which says no relationship can be determined, right? Let's look at an example so that you know what I am talking about. So look at the example on the screen. Now, we have x and y, and they are non-zero integers. And there's a condition. X is less than y, and then y is less than 0, which means that both x and y are less than 0, right? And here, y should be greater than x. In other words, x and y are negative numbers because they are less than 0. Now, quantity A says that x over y, and then quantity B says y over x. And we have to select any of these answer choices. Now, so let's do a bit of testing here. Let's choose values for x and y. One thing you need to keep in mind is that there is a constraint here that both x and y are negative values and y is greater than x. So I can say let x equals -2. Let me use, then y will be equal to -1. Of course, y is greater than x here, and both of them are negative. All right, so quantity A. What does quantity A say? It says x over y. So x is -2, y is -1. And clearly the negatives will cancel, so we have 2. Then quantity B says y on x. Y is -1, x is -2. The negatives are going to cancel, and then we have half. Now let's compare quantity A. Quantity A is 2. Quantity B is half. Which one is greater? Of course, clearly you can see quantity A is greater here. You wouldn't want to end here. Let's pick another pair to try. This time around, I'm going to pick x to be equal to, let's say, -5. And then, or let's use -3. And then y to be equal to -2. And note that the values I'm picking obey the constraint we have here. All right, so here too in quantity A, we have x over y. So we have -3 over -2, and this will give us 3 on 2. Then quantity B, we are going to have y on x. So -2 over -3, and that is going to be 2 on 3. So we are going to compare these two fractions. So we have 3 on 2. We are comparing that with 2 on 3. And you know this simple comparison, whenever we are comparing fractions, we cross multiply. So 3 times 3 is 9. 2 times 2 is 4. So clearly you can see this fraction is greater. So here too we can see that quantity A is greater. All right, you don't need to test for many numbers. But before we make a conclusion, let's look at something. Let's make a general case here. Now, if both x and y are negative numbers, look at this. The quantity A, which says x over y. Now look, we are looking at negative numbers. So always, this is going to be bigger than y over x, right? And look at the examples we picked. You see, now, x, because we are dealing with negative numbers, and at the end of the day, the negatives will cancel. You realize that with this particular one, which is the quantity A, the numerator will always be bigger than the denominator when the negatives cancel out. Then with quantity B, because the negative are also going to cancel out here, you realize that the numerator will always be smaller than the denominator. And that is why always quantity A would be greater here. So this is a general case. So we go for this option, which says quantity A is greater. All right, now let's look at the second example. Here we are given a constraint, right? A condition, rather, which says x cubed is less than x squared. So I'm going to test with some simple values. Let's use x equals half. Let me use a fraction. So when x equals half, then we have that. Let's check if it obeys this condition. So half to the power 3 is 1 over 8. And then half squared is 1 over 4. And clearly you can see 1 over 8 is less than 1 over 4. So the condition is obeyed here. So x equals half will work. So let's see. Now quantity A says x, which is half here. So we are comparing half with quantity B, which is 1. And we can see that half is less than 1. So here, quantity B is greater, right? Quantity B is greater. Let's try when x equals -1. So -1 cubed is still -1. And then -1 squared is +1. So let's see if the condition is obeyed. Yes, -1 is less than +1. So the condition here is obeyed. All right, since it's obeyed, now quantity A is x and our x is -1. So let's compare -1 with quantity B, which is +1. And here too clearly, you can see -1 is less than +1. So here, in this particular case, to quantity B is also greater, right? But I always say that when you are picking numbers, you need to be careful, because sometimes the funny thing is, some of the numbers you pick will work, but there is one counter example somewhere that you probably might not be able to figure it out, right? So even if I do pick numbers to test, I still want to make a general case, right? So let's try and establish a general case here. Now look, x cubed less than x squared. This is x cubed minus x squared less than 0, right? And I'm going to factor x squared out, and that will give me x minus 1. Now let's compare these two factors, x squared and then x minus 1. Clearly, you know that x squared can never be less than 0. X squared is always greater than or equal to 0, because it will always return you a positive number, even if x is negative. So the only factor that can be negative is x minus 1, which is less than 0. And this means that x is less than +1. Yes, so we have been able to deduce from the condition or the criteria that was given, and we have been able to show that x will always be less than 1, right, for this to hold. So if x is always less than 1, and we know that quantity B is 1, then it tells us that always quantity B would be greater. So we go for option, the second one, which says quantity B is greater. Now I need you to take note of this statement here. Note, picking numbers helps test possibilities. If all tested values give the same result, confirm with algebra, that is what I said, or by checking all important cases. If even one valid value gives a different comparison, then you would want to go for option D, which says the relationship cannot be determined from the information given. And so that's what I said. I mean, even if I test with values, I still want to make a general case by using algebra. And that is what we have done in the two examples. Now, we want to look at the second strategy, which is called estimation or approximation. Now, in this strategy, you don't want to do exact computation, right? You want to round some numbers and just do some comparison and then choose between your answer choices. Let's look at example 1. Of the 1,242 employees at a firm, approximately 38% work remotely. Which of the following is closest to the number of employees who work remotely? Ideally, if you are going to do a direct computation or an exact one, then you are going to find 38% of 1,242. And that is a bit tedious to do or a bit lengthy to do, especially when the numbers are not, values that you are familiar with. I always want to round to get some easier numbers to work around with. So instead of using 38%, I'm going to round 38% to the nearest, I'm going to round it up to the nearest tens, and that will be 40%. So instead of using 38% to do the calculation, I'm going to use 40% because that will make my calculation easier. So I need to find 40% of 1,242. Now look here. It is always easier to find 10% of any number. 10% of any number, you just have to drop a decimal point from the right. So 10% of 1,242, we just have to drop a point here, and that is going to be 124.2. Since I need 40%, that means I need 4 of the 10%. So I'm going to multiply this by 4, and that is going to give me 496.8. So approximately that will be 497. So 40% of 1,242 is approximately 497. Now, notice that 38% is a bit lesser than 40%, right? So if 40% of 1,242 is giving me 497, then it means that 38% will give me something less than this. So we need to go through the answer choices and look at something closer to 497. And when I go through, definitely, I'm going to pick my option C. That is the one that is closer to 497. And the answer is 470. Right. So that's how we use estimation or approximation to get the answer from the answer choices. Now, quickly, let's look at example 2, which I would want you to pause the video, try it yourself, and then put your answers in the comment section. So here we are doing a quantity comparison question where quantity A is 31% of 798, and then quantity B is 250. So we need to compare and know what option we are going to choose. Now, doing a direct computation, that is 31% of 798, might be a bit tedious, especially those of you who would like to rely on the calculator. You are going to waste time. So what I'm going to do is that I am going to round 798 to the nearest 100, and that will be 800. So that will work with this. So I'm going to find 31% of 800. Now here too, let's find 10%. It is always easier to work with 10%. Now 10% of 800, so you know you have to drop 1 0. That will be 80. And so we need 10% plus 10% plus 10%, and then plus 1%. That will give us 31%. So we have 80 plus 80 plus 80. Then 1% of 800 is just 8, right? So let's add this. This is going to be 248 because 80 plus 80 plus 80 is 240, and then plus the 8, that's 248. So now 31% of 800 is actually 248. Now look at something. The actual value is 798, but we rounded it to the nearest 100, which gave us 800. And you can see that 800 is bigger than 798. So that tells us that 31% of 798 will be smaller or will be lesser than 248. And quantity B is 250. So since 31% of 798 will be less than 248, it tells us that quantity B is greater. So we go with this option. So this is how we use estimation and approximation to do some of these problems on the GRE Quant reasoning problems. The third strategy on my slide is what we call the back solving from answer choices. So for standard multiple choice questions, you want to plug in the answer choices back into the problem instead of solving from scratch, right? So sometimes you want to start with the answer choices and then plug them into the problem to get your answer. Let's look at a simple one, a very basic one in example 1. We are given 3 into bracket x minus 4, and that is equal to x plus 8. And they are asking you what is the value of x. Of course, that is very simple that you would want to just solve it, but sometimes the equations are a bit complex that back solving would really help you. So it is best you get to know how to do it. All right, so let me begin with 8. You have to be fast with this when you are back solving. So if I plug 8 here, I'm going to have 3 multiplying. Now, 8 minus 4, that is still 4. That is equal to 8 plus 8. Let's check if this is true. 3 times 4 is 12. And then 12 is not equal to 8 plus 8, which is 16. So it means that the option A will not work. Quickly, we try with 10. So we are going to have 3. Then 10 minus 4, that is 6. Let's check if that is equal to 10 plus 8. Yes, so 3 times 6 is 18, and that is equal to 10 plus 8, which is 18. So quickly, you know your answer is 10, which is option B. You don't need to go through to check for the C, D, and E. Once you get your answer, you move on to the next question. All right, example 2. Now, working alone at a constant rate, pump A can fill a tank in 6 hours. Then working alone, pump B can fill the same tank in 4 hours. Now, if both pumps work together at their respective constant rate, how many hours will it take to fill the tank? That is one tank, right? Here, of course, if you want to do direct computation, like solve from the scratch, that is fine. because the problem is an easy one and you would get the answer straightforward. But let's still stick to the back solving. So I'm going to try with the answer choices, and then here you need your calculators because of some of the decimals right there. So we want, let me begin with option A, which is 1.8. So I'm going to divide that by pump A's rate of filling the tank, the number of hours it takes to fill the tank, that is 6. And then 1.8 divided by 6, that will give you 0.3. Then the same 1.8 divided by pump B's hours of filling the tank, that is 4. And that is also going to give you, so 1.8 divided by 4. Here you can use your calculator, which is easy. Now, what is 0.3 plus 0.45? That will be 0.75, and that is not equal to 1. We want it in such a way that the addition will give us 1. So quickly, option A will not work. Option B, which is 2.0, so 2 divided by 6. So let's try 2 divided by 6, and that is 0.33. Then we also have 2 divided by 4, and that will be 1 over 2. Of course, when you add this 0.5, when you add it to 0.333, you get 0.83 something, which is still not equal to 1. So quickly, you know that this is also not an option. Then we look at 2.4. So 2.4 divided by 6, and that is going to give us, let me use my calculator for this, 0.4. Then 2.4 divided by 4. So 2.4 divided by 4, that is going to give us 0.6. Now look at something. 0.4 plus 0.6, that will be equal to 1. And that tells you that C, which is equal to 2.4, is your answer. Because we want the number of hours that it will take to fill the tank, right? And that is just 1 tank. All right. Let's look at the next strategy, which is the 4th one. Simplify algebraically before comparing. So you treat quantity A and quantity B like 2 sides of an inequality. Either you add or subtract the same expression from both sides, or you multiply or divide both by a positive value to cancel some shared terms, right? Here you need to take note. Never multiply or divide by an expression of unknown sign. That is something you need to take note. Let's look at the first example. Quantity A, we are given, so X, you need to take note of this condition. X is not equal to -4. So in quantity A, we have 3x plus 12 over x plus 4. Then in quantity B, we have 3. Now, look at something. In the numerator for quantity A, we can factor 3 out. And that will give us x plus 4 over x plus 4. And clearly, you can see this will cancel that. And in quantity A, we are left with 3. Quantity B, too, we have 3. So clearly, you can see they are the same. So you go for the option, the 2 quantities are equal. So here we simplified, right? We simplified, cancelled out certain terms, and then we realized that actually quantity A is 3 and quantity B is also 3. So the 2 quantities are equal, or they are the same. All right, let's look at the second example. We are given y to be equal to 4x plus 7 and z to be equal to 4x plus 3. So quantity A, we have y, and then quantity B, we have z. So let's look at, now let's write y. Y is 4x plus 7, right? And then z is 4x plus 3. Now let's subtract the same term from each side. So I'm going to subtract 4x from quantity A and subtract 4x from quantity B. So minus 4x minus 4x here. So clearly this will cancel that and we are left with 7. This will also cancel that and we are left with 3. Now we are just comparing 7 and 3. Which one is greater? Clearly 7 is bigger than 3. So here we go for the option. Oh, the option didn't come. Okay. So clearly here you are going to go for quantity A is greater. That is the option you are going to select. I hope this lesson was useful. And this particular video is useful for those who are new to GRE and would like to explore the quantitative section. All right. Have a nice day. Now, I will advise you, before I go, I will advise you that if you want to be good at these strategies, you need to practice them. Do a lot of practice. Practice them with plenty questions or problems to become a master of these strategies. And it's going to help you a lot. All right. Have a nice day.